Okay, hello everyone. That's very well to find all of you to back to this channel. So today's we want to so this movie class we want to talking about physics quantities and the scientific notation. Okay, so the first is about the units. So and when we're talking about the units, we will focus on the two important topics. The tools there's so the section the first eight parts we want to talking about the fundamental of quantities, and the second we want to talking about the derived quantities. So this is an important topics in our high schools, and it's really common question and quiz for the exams for the students. So we can focus on all of these ones. And here's the fundamental physics. The mass, length, time, temperatures, and current amount of the substance and the luminance. We all know this. This is the very important seventh fundamental unit over here. And there's an organization called Standard International Organizations. He proposed that there's some fundamental quantity in this one. So the first is the mass. And the mass, the units we often use the units is the unit of the mass is the kilograms. Okay, and so we want to try to describe the mass of the. We want to try to introduce and try to calculate the mass. Means that we want to know that these objects can be affected by the force will be easy or maybe will be not easy. And also that the second is the length. Well, I think the length is just means that we use kind of longs. Maybe we want to know that the thing is long or short. So we use a common unit is the meters. Okay, so the time is really clever to understand that. Yes, we use the second. Maybe the second, or maybe a nanosecond, millisecond, picosecond, and the femtosecond, like this ones. Okay, so the second means that we want to try to understand what is the most important topics. We want the time means that want to calculate the how fast ideas or maybe an object to complete and things their intervals. How do this ones. Okay, so the first turn thing is the first important topics. First important quantity is the temperature. Okay, so the temperature means that we often use the case. Okay, so this case Unix actually he is wrong to describe this is not famous for not familiar for all the students in the junior high because that and in we use the maybe you will pass we use the this one and the Fahrenheit all these the signals, these signs to describe the temperature. However, while we use the K's mean the kelvins, and the kelvins over here, so we just use this one to describe the motion of the molecules. Okay, so if you want to, describe some things, you want to describe the atom something, or maybe you want to describe the molecules, atoms or molecules, the motions. You will find this will be great to understand this one things. Okay, and five, we're talking about the current, and current is really common Unix is used ampere. So, however, the amperes actually means that the charge over per second. Okay, so the six is the amount of the substance means the moles. So we use the mole to calculate something, the numbers of the atoms or maybe the molecules. Okay, so there's a really common is the 6.03 times the 1023. Okay, so this is really important numbers of the numbers of the substance. And okay, so the final is the luminance. Okay, so luminance we use Unix is a CD and candela. Candela means that you want to, and this quantities you want to describe that something will be shine, maybe the has some objects will be shining on the shinings or maybe sparks. So you can calculate and you can know that the magnitudes of the luminance. So all these seven fundamental quantities really important topics in this section. So all of you got to memorize this because that all the exams and maybe all the exams and also the quiz will be very common problems in all this one. Also the entrance exams will be very famous in the past decades as well important. Okay, so the second we want to this pocket we're talking about the derived quantities. Okay, so the derived quantities means that something you got to you want to if you want to behave, got to use the k. You want to mass of length of all these seven units in fundamental units can to describe the quantities. So the first one will be like the velocity. Okay, so we know that the velocity in the junior high school we have already definitions. So it means that here is the displacement. Okay, so this velocity is the displacement over the time, right? Okay, so if you want to behave or me will be the signs. This one we will use the meters per second. Okay, we can use the meter per second. And also, if you want to know the acceleration. Okay, so it means that is the variation of the velocities over the time in variations. So the units will be used the meters per second squared. Okay, so here's there's lots of very common derived. There's a lot of the very common quantities derived quantities that I just address some important examples. And also like this the kinetic energies. Okay, so in the formulas of kinetic energy is 1/2 times v and v squared. Okay, so the so the units will be the kilograms times the meter per second squared. Okay, and also this is the kinds of we will use units to describe it, or maybe we use to code it joule. In Chinese, it's joule. Okay, so and also like the power. Okay, the power in Chinese is called 功率. So the 功率is here is the definitions is the time is the worth over the time. Okay, so the over time means the joules over per second. Okay, over the time, over per seconds. Okay, so this is really Palmer's we call derived quantities. So when there's a lot of the entrance exams will be very famous and very common problems to. So you got to review all of this, and I suggest that all of you got to memorize all these 7 fundamental quantities. Now, however, that the derived quantity is very lots of the derived quantity. So you just memorize that the idea is you got to use the fundamental quantities to behave this quantity, physical quantity to do this. Okay. Okay, so when you finish the physical quantities here, I want to introduce the scientific notation. And I know that lots of students maybe have already learned the scientific notation. So I got just here, I just reviewed about these ideas. So the first one will be that the 3.28 times this one. Okay, so here is that if you want to describe the scientific notation, these terms you got to the a terms you got to smaller than the times and bigger than one. Okay, and also if we want to have these ideas this way, we call this is the b, and this b is always often will also use this is the negative, will be the integers. Okay, we will use the integers to be to behave like these ones. Okay, so this is the scientific notation. And then, so let's do some practice. So let's if something you want to be use the notation, the scientific notation like this one. This is 1,250. There's numbers like this one. You want to behave like the scientific notation. And so the first one you got to use is briefly into the 1.25 and times the 10 squares, like this one. Okay, so and also that if you got there's a float or maybe the double numbers, that is one. So if you can you can briefly into the 5.3 and times the 10 minus 4, just nice one. Okay, so this is the scientific notations. And the second and the first the point is about the orders of a magnitude. So what is a magnitude? It means that you want to behave something like this one. Okay, so okay, we know that actually in our science detection, there's lots of numbers you got to use, and when you want to use a notation, it means that the scientific notation, this one, we can just use these ideas to help us to briefly our calculations. However, this and the approximation. So the order of the magnitudes actually we want to do the things is doing the approximation. Okay, what we want to do is the approximation. So 1.989 times this one, and actually it just nearly the approximation is also just like the 10.8. And this is also if these numbers is bigger than okay, so it's bigger than the square temp, and the square is approximately that is 3.16, and you can finally to get these numbers. Plus 1. Okay, so you will find this there's the same. We will say this and they have the same orders. Okay, so this idea can help us to briefly to talking about what is the most important factors in all these numbers. We know that lots of the elements, and when we do the experiment, there's a lot of the elements and lots of the factor will be affect our experiment. However, we got to find out what is the most important topics. So the magnitudes and the order of magnitude is very important to help us to do these things. Okay, so however, that when we start to do the more experiments, can help us to know this idea is important. Okay, so now here's the finals. We want to talking about the physics quantities. And we're talking about the when we're talking about the quantities. Okay, the quantities, and we from the quantity into the notation, and we know the orders, and finally we'll find that including the orders and maybe the notation, that there's lots of numbers like this one, 8, and or maybe the 9, 12. However, you want to use this into the letters, we will use this symbol to do. We will use a symbol to symbolize all these numbers. So just like the kilograms, the 1 kilograms means that is the 10 third meters. Okay, and also there's the 5 micrometers means that it's 5 times 10 minus 6. Okay, so we use the K, M, G, and here is the K is this one, this way. This is the digit, and tetrad. This is 10, 12. Okay. And also that if you, the terms is negatives, so we can go back into this one, the millimeters. So this m means that 10 minus 3, and micrometers. So this is a 10 minus 6, and this is the picometers, the 10 minus 9. And this is the picometer and the femtometers. I'm sorry, not this, nanometers. So you use the n letters, and 10, 12. This is the picometers. Okay. Okay. So this is all the important scientific science in our daily lives, and in our daily lives, there's lots of the scientific science. So all of you can help us, like the nanometers, because today in Taiwan there's lots of the silicon. There's lots of the semiconductors. So we will use the nanotechnologies. So here's the nanotechnologies means that the the matter will be find out something in the nanoscales. So the nanoscale means the microscopic, the scope. Okay, so the nanoscale and the microscopy ideas that. And when we ice, we can only focus on the macroscopics. So when we try to downsize the chips into the nanoscales, and we will make our chips can go faster and go convenience and have a well powerful to do the calculations. So this is a really important topic to do this over these things to do that. Okay. Today this is our about the scientific. Today we're talking about the quantities and the notation and the order, and finals we're talking about the scientific science to symbolize all the letters. Use the letters to symbolize our ideas. So all these things we got to focus on. Okay, so thanks your today's focus on these videos. So the next video we were talking about the chapter 2 about something the matters compositions. That will be very interesting for all of you about the history of the compositions. Okay, so see you next time. Bye.